Hello. So in this video, we are going to discuss how to design, run, and analyze the output of the regression model. And we will do this based on the example of Keynesian model. So long story short, under the Keynesian model, change in national output is equal to the product of change in government spending and Keynesian multiplier. We also assume, at least this is what theoretical model tells us, that the value of Keynesian multiplier is always bigger than 1. So we want to check whether this is true, and we estimate the following regression model. So y in period t is equal to beta 0 plus beta 1 multiplied by g in period t. So here YT stands for US GDP in quarter T, and GT stands for the volume of government spending in quarter T. So we will analyze everything based on time series data. As you remember, in this kind of data set, we analyze the same unit for several periods. So here we analyze US economy for several quarters. So we collected some statistical data, namely quarterly and seasonally adjusted data on GDP and quarterly and seasonally adjusted data on government spending. So at this point, it might be really unclear what it means seasonally adjusted and why it is better to use seasonally adjusted data rather than non-seasonally adjusted raw data, but I promise we will get back to this in the next lecture. As for now, you can just keep in mind that it's always a safer option and you are likely to end up with more reliable output of the regression model when you use seasonally adjusted data. So we collect the data. This is the way we have to organize the data set. Obviously, all the observations should correspond to the same period. So, yeah. So later, we can use Gretel for this purpose, which is quite a useful tool. So, as discussed before, we go for ordinary least squares, which is like the simplest possible form of the regression model and also the default option in most of the cases. So we choose ordinary least squares. We have to specify the dependent and independent variables, and this is what we end up with. So this is the typical representation of the econometric model regression output. So here const stands for constant, or the value of beta 0 in the equation we've discussed before. So this is like the independent term, the value of vertical intercept of the regression line, or this is the value of national output or GDP when the value of government spending is equal to 0. So we've got this. We've got coefficient for G or beta 1 in our equation. Basically, we can interpret it in the following way. If you increase government spending by $1, then GDP is going to increase by $2.78 approximately. Also, we've got p-value. So here, the null hypothesis states that the value of coefficient of the variable is equal to 0, implying that government spending causes no effect on the level of output. Here, we can reject the null hypothesis at 1% significance level, so our p is smaller than 0.1, which is like the upper boundary for statistical significance when you interpret econometric model output, but also it's smaller than 0.01. Of course, we've got some statistics as you can see into the columns below. But this is something we are to discuss during the next lecture, not now. Basically, this is what helps you to assess the goodness of fit of the model, to figure out whether your model was designed appropriately, whether you didn't violate any of the crucial assumptions for data and econometric procedure. So yeah, we're gonna use it next time, but definitely not now. So actually, another thing you can do is to put predicted values of output. I mean, the values predicted by your model. So this is what blue line stands for, with the actual empirical values. So as you can see here, everything is pretty close. And unless there are some deviations in this area, for instance, in general, this relationship between government spending and GDP can indeed be described by the linear function. Okay, and finally, we can use information about the link, between government spending and GDP for formulating some policy advice. Actually, this is what we typically use econometric research for. So in this case, we figured out that one additional dollar of government spending increases GDP by $2.77, and this result is statistically significant, which means that we can indeed trust this result. And imagine that government estimated that GDP should go up by 28 billion in order to avoid the recession. So, since we know the relationship between government spending and GDP for the US economy, we can calculate that government spending should increase by roughly $10 billion in order to achieve this policy objective, as simple as it is. Okay, so that was it. Thank you for watching and see you in the next video.